Okay, y'all, here we go. So, some of the problems from the test that you guys had yesterday, again, we're struggling a little bit on distributing and combining like terms. This will be a problem when we get into our higher level equations and when we start graphing linear equations, which are straight lines on a graph. We need to make sure that we know how to do this. Even if you're happy with your grade, we're at the beginning of the semester, right? You can retake it in the Learning Commons, in Life Prep. Like, it doesn't take a lot of work to fix your mistakes, really. So I would love for you to do that. Turn it in on a separate piece of paper with your test. So your test, separate piece of paper with the corrections, give it to me. I'll check them. I'll show you which ones you did right or wrong. You'll get partial credit back for it, okay? You might as well raise your grade. There's no reason not to. It doesn't take that long. Fair enough? Okay. Thank you for the support and talking back to me. I appreciate that. All of you just stared at me like I was the wall. Cool. Not naming name table. Still staring at me like a wall. Or you're just staring at like what? Like did like I just like change something? Have you seen those cartoons where you're like staring at something and it like changes into like a popsicle or something? Like is that what's happening? Like you're like daydreaming about something else?
No, I'm just not
awake. Okay, here we go. So, listen. This was one of our more missed questions on the test. When we are distributing, we distribute with smack dab in front of the parentheses. Grouping symbols and something in front of it will always mean multiplication. In this case, what's smack dab in front of it is this negative sign. So before I do anything else, the 5x is not going over to this. It comes down. Then, what am I really distributing? A negative, what?
negative 1.
Yeah, negative 1. Negative 1 times 7 is negative 7. We keep the x. Then I do a negative 1, and this is where I saw the mistakes. Negative 1 times a positive 2 is a negative 2. Have to make sure that you're including the signs when you do this. I had a lot of people just taking a negative 1 to a 2 and then still putting positive 2. Okay? It's negative 1 times a positive 2. Now, when we combine like terms, think about the names. We have our x-ray machines. I have 5 x-ray machines and negative 7 x-ray machines. I know that I'm going to be dealing with x-ray machines. So all we care about is the 5 and the 7. So now I'm reading it. 5 minus 7 is negative 2 x-ray machines. I do not touch the constant. It's negative 2. Questions on that? Okay. This goes back to one of our very first lessons. When we're multiplying fractions, we multiply across. So I multiply. 3 times 8 is 24. I multiply my denominators. 8 times 3 is 24. 24 divided by 24 is 1. Okay. I'm going to put a star next to that because we're going to be coming back to that. Okay.
0 and 2.
3, 4, and 5 are all the same answer. They're also all the same question.
0.
Yeah, they're all going to be 0. But what I want you to understand is a negative 12 plus 12 is 0. Those are opposites. When I add opposites, it's going to give me a 0. 12 minus 12 is the same as 12 plus a negative 12. These are equivalent. Same value, looks different. 12 minus 12 is the 12 and the negative 12. I can say 12 plus negative 12 is 0. Those are still adding opposites. But Mr. H, we're subtracting. Any subtraction problem can be rewritten as an addition problem. And I need to say that again because you're going to hear this a lot. Any subtraction problem can be rewritten as an addition problem. Questions? Okay. So let's get going. Not a lot of a lesson. And again, Mr. Keller taught you guys really well. I truly believe that the year has been easier for me because of the groundwork that Mr. Keller did. So, I'm hoping that you guys are like, oh yeah, I remember this, Mr. H. For the first couple lessons, you guys should crush this. We will probably have a quiz on Monday. I know, Mr. H, that's ridiculous having a quiz on a Monday. Yeah, but trust me, you're going to be ready for it and there's not going to be a problem. we are going to do some properties and one-step equations. Okay? There are really only two properties that I need you to understand. The first property that we use is the additive inverse property. And this is what I just showed you. The additive inverse property says, hey, I have 12 plus a negative 12. They're opposites. When I add opposites, they give me a 0. When I add opposites, negative 7 halves plus 7 halves. It doesn't matter if it's a fraction. It doesn't matter whether it's a whole number. It doesn't matter. Okay? Rational, irrational. If I add the opposites, they will always equal 0. Okay? Everybody with me there? Have I lost anybody? And I told you I was going to show you two properties. I need to show you this one too. Additive identity property. So I'm going to show you 3. The additive identity property says, okay, well, let's say I have a negative 4/5 plus 0. If I have this and I'm adding it to 0, I still have the negative 4/5. If I have negative 323 plus 0, yeah, it's still negative 323. So the additive identity property says anything plus 0 is that anything. Where here, anything plus its opposite is 0. I mean, we good there? I know this is basic. I know you're like, when am I ever going to use these properties? Most math teachers, and listen, I have observed a lot of classes because not only have I been a teacher for 19 years, for several years I was an instructional coach, which means I was observing the teachers and that's what I did every day. Like I would teach the teachers how to teach. It's a lot of teaching. So when I say that a lot of teachers don't use these, it's why we don't understand why we're doing something. We might be able to do it, but we don't understand why. These properties are why we solve equations the way that we do. Last one. So this was number 2, number 1, number 3. Okay? Is the multiplicative inverse property. Okay? Now, here's what I need you to understand. There is no division property. It is always the multiplicative inverse. Mr. H, how about you show what that means first and then we'll go. Sure. The multiplicative inverse says a number by its reciprocal. The reciprocal of 4 is 1 over 4 because any integer can have a denominator of 1. Okay? A number multiplied by its reciprocal. Reciprocal means we flip it. Yeah? Reciprocal. Try again. The numerator becomes the denominator becomes the numerator. When I multiply this, that gives me 4 divided by 4, which is 1. That's example 1. Well, what if I have a negative 3 halves? What would I have to multiply negative 3 halves by to get 1? Not negative 3 halves, negative, huh? Negative 2/3. But Mr. H, why is it a negative as well? Great question, I'm glad you asked. Negative times a negative is? 3 times 2 is positive 6. 2 times 3 is positive 6, which is positive 1. Okay. Wait a minute. Mr. H, there is no division property. 5 divided by 5 is 1. which is really saying 5 multiplied by the reciprocal. Because remember, wait a minute, we did fractions. That was the very first thing that I did. And there's a reason why. When we divide a fraction, it is keep, change, flip. I keep, I change, I flip, which still gives me 1. So when we're dividing, we are still using the multiplicative inverse. Okay? We will be using these properties. Questions so far? I'm going to give you a second. I'm going to make sure we haven't copied down. I'm going to erase them because I need the board. Good? Katie, are you good? Vivian? Who else? Nora? Mm-hmm. Nora's like, I've checked out like 5 minutes ago this rage. Mm-hmm. Nothing. You're good. Okay. So, one-step equations. Y'all, I have no doubt that you can probably solve 7 out of 10 one-step equations right now without me even worrying about it. And can I tell you that I taught one-step equations poorly for many years? Like even up till last year, probably I'm like, I did this poorly. So the first thing that we need to do is talk about inverse operations. And I used to write the symbols, a plus, a minus, a multiplication, and division, and I realized that was not the right thing to write. Okay? The inverse of addition, which means the opposite. The opposite of addition is subtraction. The opposite of subtract is add. The opposite of multiplication is division-ish. Because remember, we know that division is really multiplicative inverse, the multiplicative inverse, but we'll get there. And then the opposite of division, the inverse, is multiply. The goal of any equation, is to isolate the variable. That is, if you get stuck and I say, hey, what's the next step, Abel? You can always say, I need to isolate the variable. Yes, at any point, this is still the right step. We want to isolate the variable. Because I've had people say, oh, we just want to solve it. No. That's not the end goal. The end goal is to get the variable all by itself. Isolate means get it by itself. Everybody with me? Have I lost anybody? So, I will give you steps probably tomorrow. A rundown of steps for 99.9% of equations. I don't want to do that today because I don't want to limit your thinking. So here's example 1. I have 5 plus x equals -7. Now, before we even start this, which I know that you guys know how to solve. I know y'all know how to solve this. The goal is to isolate the variable. That means get x by itself. What is x? I don't want an answer. What does x represent? What is a variable? We've talked about it.
A number that we don't know.
Yeah, an unknown value. Okay? X is some number that when I add it to 5 is -7. What we do with my son is 7, and he can solve basic equations. We play a game of hide and seek. I'm hiding some number. 5 plus some number is -7. We just don't know what this number is. Okay? So what can we do if we're going to try to play hide and seek? Well, this 5 needs to go chase and catch that -7. right? When you play hide and seek, you have to go find them. So this 5 is going to go find them. Okay? Now, here's some things that I want you to do on every equation. It's not as hard at first. It will be as we go and it gets more important. I want you to find a balance point. So, I didn't get to do my favorite thing because I haven't done this in a long time. But equations are all about balancing. Let's see if I can still do this. I truly don't think that I've done this for a long time. Equations are all about balancing. Here we go. So, when I balance, okay, as I balance, notice how I'm going forward and backwards. Ow! Ow, my toes! Why didn't anybody say there was a stool there? Ow!
This is stupid.
Thank you.
Bro, evil.
Ow! Okay, so, as you're balancing, it has to go and find something that's going to make me stable. First, I thought I was good at handstand. Like, I was up for a while. I'm a 40-year-old man that just did a handstand in math class. You good? I hate you all. Thanks, Abel. Okay. So, there has to be some point that makes me balance, right? Like, if my shoulders are out of line, like, then I start wobbling, and then I hit a stool that nobody told me about. You didn't even ask if I'm all right. You're just laughing at it. Like, at least say, Miss Rachel, all right? No, I think I broke my foot. Oh my gosh. Jerks. So, we need to find the balance.
Wow, man.
Okay? We need to find the balance. Remember how no. So, where's going to be the balance in an equation? The what?
The equal sign?
Yeah, the equal sign. Because what's on the left, listen, what's on the left has to be equal to what's on the right. And I'm not going to do that again. So, if I balance, oh my gosh, my back hurts. Like, I hurt myself a little bit. If I balance this tissue box, it should be right in the middle. Like, see, ow! Are you all right? Sorry. Okay. So if I balance this tissue box,
Yeah, no spin.
okay, it's right in the middle. If I don't have it balanced, it's going to fall over, right? So when we balance an equation, we want to put the balance point. There's the balance point there. I've lost the marker. There it is. Now, the goal is to isolate the x. So we need to get rid of this 5. How do we move this positive 5 away from the x?
Subtract it.
Yeah, we're going to subtract 5 from both sides. We're using the inverse of positive 5, which is subtracting. Now, notice I have to do it to both sides. Because, and I'm going to come over here. Okay, we're balancing it. Please, let's do this safely. You ready? If I put 2 fingers on this side, notice how it starts to come unbalanced. Do you agree? Put 2 fingers on it. If I remove 2 fingers, all of a sudden, good catch, it becomes unbalanced. When I change, listen, when I change one side, I have to change the other the same way to keep it balanced. Okay? So now, why does this work, Mr. H? Well, the goal is to isolate the x. 5 minus 5 is the same as 5 plus a negative 5. This is the additive inverse property, which leaves me 0 plus x equals negative 12. Do I actually need to put a 0 plus x? Well, no. There is a property that tells me 0 plus anything is that anything. That's the additive identity. So when I have 5 minus 5, it's 0, but 0 plus x is x. This is my answer. X is now isolated. X equals negative 12. So I've used the additive inverse and the additive identity property. How many teachers in your past have said 5 minus 5 cancels? Right? Like, I'm guessing you've heard cancels before in math. It doesn't cancel, it becomes 0. Okay? So let's look at another. We've got x divided by 3 equals 7. First step is the balance point. So I find the balance point.
And not hit the street.
Okay. On a side note, like my toe really hurts. Like I wasn't really joking. Like I'm worried that I popped the nail off. That's kind of what it feels like. You know how you catch your nail on something? Oh, it hurts. Okay. What's the problems on this left side? Division. So what's the inverse of division? Multiply. And this is where it gets a little bit tricky. I'm multiplying, but it's the multiplicative inverse. So I'm multiplying by a 3 over 1. So I'm multiplying by a 3. Do I need to put over 1? No. So why does this work? Okay, I'm only going to show you this once so you understand what we're doing. We're not multiplying the 3 by the 3. I'm multiplying 3 times the x, which is 3x, divided by 3. What is 3x divided by 3? Well, 3 divided by 3 is?
0.
Not 0. 3 divided by 3 is 1. 1 what? 1x. Or just x. Because when we isolate, we want one of them. Or just x. 7 times 3 then is 21. Okay? Is this, you're hopefully starting to remember doing this last year? Because I know that you guys have done this for probably 2 years now. Okay, here's example 3. Let's go negative 5x equals negative 25. This one's tricky. This is the one that I will see you make most of your mistakes. Let's find a balance point. I can tell you that the mistake that most kids make is look at this and try to add 5. That's not correct. You need to read this side of the problem. It says negative 5x. Well, what does negative 5x, when they're smack dab, actually mean? Multiply. So the inverse of multiplication is division. So what are we going to divide by?
5.
I love that you said that. Okay, I love that you said that. Now, what's a negative 5 divided by 5?
That's 1.
No, it's not.
0.
It's negative 1x.
Same thing.
It's not. Negative 1x has an isolated. We want a 1x. So doing this does not help me. Not only am I going to take the number and divide, but I also have to keep the sign. I'm dividing both sides by a negative 5. Because negative 5 divided by negative 5, listen, that's the multiplicative inverse, is 1. 1 what? 1x. And then negative 25 divided by negative 5 is positive 5. How can I check this, Mr. H? Well, remember, a variable is an unknown value. I can substitute it in and say negative 5 times 5. Oh, that's negative 25. Last one. Let's go. Negative 5 plus x equals 2. I was acting for a while and then it really hurt. I think I hit that hard. What? You can laugh now. I'm fine. No, well, you were laughing before. You can laugh now. It's fine. I'm all right.
No, because you're hurt now.
A little bit. Okay. Thank you for not laughing now. I appreciate it. Okay, here we go. Balance point. Always equal sign. Okay, the balance point is going to become more important the longer these equations get. Yes. I promise you, like we are doing variables on both sides this year where you're going to have 6 and 7 steps. Like you need to be able to do this. So now, this is negative 5 plus x. So it's a negative 5. What do we need to do to a negative 5 to get it to be 0? So I have 1x.
You add 5.
We add 5 to both sides. Remember, you have to do it to both sides. Why? Because of that balance. If you push me this way, I have to try to balance back out the other way. If I add 5 pounds to one side, I have to add 5 pounds to the other side to make it balanced. Here we go. Negative 5 plus 5 is 0. That's the additive inverse. 0 plus x is just x. 2 plus 5 is 7. Okay? Best lesson I've ever done? No, because I hit a stool and my toe hurts. Are you going to have homework?
No.
No, it's Wednesday. But
It is?
I would like you,
No.
there's 30 questions. Okay? I would like you to choose 6 to 10 and do them now. Okay, just choose 6 to 10. I'm not grading this as a homework. I'm not doing any of that because it's Wednesday. You're not going to have homework. But I would like you to choose 6 to 10 of these to try to have done. Okay? Are there any questions? Hey, good job, Bill. Proud of you guys about your test, by the way.